Our knowledge can only be finite, while our ignorance must necessarily be infinite. Karl Popper. The universe, which others call the library, is composed of an indefinite, perhaps infinite number of hexagonal galleries. In the center of each gallery is a ventilation shaft, bounded by a low railing. From any hexagon one can see the floors above and below, one after another, endlessly. The arrangement of the galleries is always the same. 20 bookshelves, 5 to each side, line 4 of the hexagon's 6 sides. The height of the bookshelves, floor to ceiling, is hardly greater than the height of a normal librarian. One of the hexagon's free sides opens onto a narrow sort of vestibule, which in turn opens onto another gallery, identical to the first, identical in fact to all. To left and right of the vestibule are 2 tiny compartments. One is for sleeping, upright, the other for satisfying one's physical necessities. Through this space too there passes a spiral staircase, which winds upward and downward into the remotest distance. In the vestibule there is a mirror, which faithfully duplicates appearances. Men often infer from this mirror that the library is not infinite. If it were, what need would there be for that illusory replication? I prefer to dream that burnished surfaces are a figuration and a promise of the infinite. Light is provided by certain spherical fruits that bear the name bulbs. There are 2 of these bulbs in each hexagon, set crosswise. The light they give is insufficient and unceasing. Like all the men of the library, in my younger days I traveled. I have journeyed in quest of a book, perhaps the catalog of catalogs. Now that my eyes can hardly make out what I myself have written, I am preparing to die, a few leagues from the hexagon where I was born. When I am dead, compassionate hands will throw me over the railing. My tomb will be the unfathomable air. My body will sink for ages, and will decay and dissolve in the wind, engendered by my fall, which shall be infinite. I declare that the library is endless. Idealists argue that the hexagonal rooms are the necessary shape of absolute space, or at least of our perception of space. They argue that a triangular or pentagonal chamber is inconceivable. Mystics claim that their ecstasies reveal to them a circular chamber containing an enormous circular book with a continuous spine that goes completely around the wall. But their testimony is suspect, their words obscure. That cyclic book is God. Let it suffice for the moment that I repeat the classic dictum: the library is a sphere whose exact center is any hexagon, and whose circumference is unattainable. Each wall of each hexagon is furnished with 5 bookshelves. Each bookshelf holds 32 books identical in format. Each book contains 410 pages. Each page 40 lines. Each line approximately 80 black letters. There are also letters on the front cover of each book. Those letters neither indicate nor prefigure what the pages inside will say. I am aware that the lack of correspondence once struck men as mysterious. Before summarizing the solution of the mystery, whose discovery, in spite of its tragic consequences, is perhaps the most important event in all history, I wish to recall a few axioms. First, the library has existed ab aeternitate, the truth whose immediate corollary is the future eternity of the world no rational mind can doubt. Man, the imperfect librarian, may be the work of chance or of malevolent demiurges. The universe, with its elegant appointments, its bookshelves, its enigmatic books, its indefatigable staircases for the traveler, its water closets for the seated librarian, can only be the handiwork of a god. In order to grasp the distances that separates the human and the divine, one has only to compare these crude, trembling symbols which my fallible hand scrawls on the cover of a book with the organic letters inside, neat, delicate, deep black, and inimitably symmetrical. Second, the Library of Babel was written by George Louis Burgess in the 1940s, and given both its topic and its impact, it's a bit ironic that it's only about half a dozen pages. We just finished hearing the first one, and the rest is well worth a read and is freely available online, but seemed a good introduction to a discussion of not just the topic of the Library of Babel, but some parallel concepts, like if we gave an infinite number of monkeys some typewriters and asked them to write us some Shakespeare, and some modified versions like the Library of Mendel, the Great Archive of All Life, the Chronicles of Everyone's Story, the Akashic Records, the Encyclopedia Galactica, and even how modern AI, search engines, and ChatGPT might play a role. In a grander sense, we'll be talking about infinity, infinite archives, the problems with that, and what our approach to the infinite and eternal might be. Given the topic, there's a lot to discuss, so a drink and a snack might be in order. And don't forget to hit the like and subscribe buttons while you're at it. The Library of Babel, rather appropriately, has a lot of philosophical layers to it. The sheer scale of the library can evoke feelings of insignificance and futility, as finding purpose within the vast expanse seems impossible. Nothing you do there can possibly be significant, and even finding a single useful tome is unlikely, even as you're surrounded by literally every possible book ever written, every bit of knowledge in existence. So it questions the fundamental nature of knowledge and how we can discern meaningful information from an overwhelming sea of possibilities. Also, as we'll be discussing possibilities and quantum today, it is worth noting that the library's structure, which includes sleeping chambers and everything needed for librarians to survive, suggests a deterministic universe where all possibilities are pre-written and to which some purpose exists. Yet the randomness of the book content emphasizes the unpredictability of finding meaning in anything. I find that dichotomy fascinating to consider, but we're going to be focusing more on the physical scale and implications today. Still, those philosophical aspects are more relevant to contemplating the original short story itself, and again, it is well worth the read. The Library of Babel, as our author describes it, is somewhat arbitrary, and would not actually have to be infinite. Each book in it is 410 pages long, and filled with random gibberish. Were you to be writing it, you would be randomly picking each new character from the allowed list and filling the page with it, then the next 409 pages too. Every so often some random assembly of words will exist and be meaningful, not even that rarely either, but the longer the phrase or sentence, the less frequently it will pop up. Order can appear to rise out of utter chaos, and patterns emerge, some potentially self-perpetuating. Somewhat poetically appropriate, the shortest multi-word sentence in English that I am aware of is "I am," and thus "I am" is the first and most likely statement to arise from chaos. As to the odds themselves, if we assumed we were using modern English and just had 28 characters, the 26 letters plus a space and period, then the odds for I rising is just 1 in 28. The odds of it being followed by a space are also 1 in 28, and the same for the A, M, and period. The odds of finding them randomly occurring in a given spot are 1 in 28 to the 5th power, or 1 in 17,210,368. That is more characters than are in even a very long novel. Those in the Library of Babel are 80 characters a line, and 40 lines a page, 3,200 characters a page, and 410 of those in each book, or 1,312,000 characters a book. So you'll be less likely than not to find "I am" in there. Though you would find many words or phrases randomly in such a book, more in the original library too, as the author wrote it in Spanish and stipulated only 22 characters, the comma, the period, and the space. Let us assume we kept to English but just booted the letters J, X, and Z, which Samuel Morse counted as the least common letters when he was developing Morse code. We'd be down to 25 characters and could then spell "I am" as 1 in 25 to the 5th power, or 1 in 9,765,625. If we drop the need for the period at the end, this would drop to just 1 in 390,625, and now it would be surprising if we didn't find it in your typical novel-length pile of random gibberish. As you might guess, the name Babel is a reference to the vast Tower of Babel and its story, which in the Bible ends with humans scattered to the four winds speaking gibberish at each other, where once they had a single unified tongue. This, incidentally, is where talk of infinite monkeys typing comes from, and Borges had traced the idea or parallels back many centuries to Aristotle himself. For the monkeys, if you had them banging away the keys producing gibberish, then every so often they're going to produce some words. I first encountered the concept as a kid watching The Simpsons during its fourth season in 1993, Last Exit Springfield, where Mr. Burns has a room with 1,000 monkeys in it typing to create a great novel.
It was the best of times. It was the blurst of times. You stupid monkey! You shut up.
And he checks what one wrote and gets angry to see it was the best of times, it was the blurst of times, as a typo of the classic opening line of Charles Dickens' A Tale of Two Cities. If you're curious, using our 28-character option, the odds of getting the proper opening, it was the best of times, it was the worst of times, containing some 51 characters, would be 28 to the 51st power, which in base 10 is 6.4 times 10 to the 73rd power. That's about 3 million times as many atoms as are in the Milky Way galaxy, and it takes a lot more than a single atom to write a letter on a piece of paper. Indeed, it should be somewhere around 100 billion atoms per character, depending on how thick your paper is and how big you are writing. We will go with a nice round figure of 1 milligram per character though, and note that even in a library not composed of books, but rather thin ribbons of paper just long enough to hold that 51 character phrase, then you have a library massing about 10 to the 68th kilograms. I am rounding up a bit to assume some mass for the structure holding all these ribbons of paper. That is a million billion times larger than our estimate for all the regular matter in the observable universe, and if we pillaged various other universes for the matter to get it, would give us a library some 30 trillion light-years in diameter, or about 300 trillion times wider than the observable universe. So Mr. Burns is going to need a lot more monkeys. And our Library of Babel, which would have to be much bigger yet, is not able to exist anywhere in this physical universe. But far more complex things can arise than that simple statement, and indeed must do so if you're in an infinite universe. This comes up a lot when we try to imagine things like a Boltzmann brain, where a random assembly of particles has formed a thinking brain. In an infinite universe, this must have happened, and many times. And even in finite versions of a multiverse, as dictated by many worlds' interpretation of quantum, this event is fairly common in comparison to the vast immensity of possible universe states. If each book of those books in the library actually existed and only once, at 1,312,000 characters a book and 25 character options, that's 25 to the 1,312,000 possible books. Mind you, any work consisting of more than 1,312,000 characters, say any novel by Brandon Sanderson, would not exist at all, though you might find Part 1 and Part 2 of a given book in that library, along with many sequels to novels of his I've been patiently waiting for, and for that matter, Winds of Winter by George R.R. Martin. So too, with most books being shorter than 1,312,000 characters, there would be a huge number of books there that contain the whole text, but starting partway in and ending before the last page. There would also be way more that consisted of the work but a single typo, like with the work the monkey gave Mr. Burns, and even more with 2 or 3 or 20, which is still better than most books written before spellcheck tended to have, in their first edition anyway. 25 to the 1,312,000 possible books. What even is that number? I pumped that into my calculator on my PC to get the decimal version, and it gave me back invalid input. I had to ask ChatGPT, and even then, it asked me if an approximation was okay, which was 1.956 times 10 to the 1,834,097. A number, in fact, and totally non-coincidentally, too long to write out in one of the books in the Library of Babel, digit for digit. For those who are curious, we do have something better than exponents for writing out very large numbers, called tetration. In my 25 years as a physicist, I have never used it for any physical problems, just for when mucking around with multiverse or repeating universe concepts, but we'll explain it briefly. In math, we have what are called hyperoperations. The first one is addition, and the second is multiplication. Just counting one at a time is considered the 0th hyperoperation, as you're just adding 1 each time. 1, 2, 3, 4, and on. So you can add a number to itself or to some other number, the first hyperoperation. Then you can multiply instead, adding a number to itself as many times the second number says. 4 times 5, 4 added to itself 5 times. Your next level, the third, is exponentiation, where we multiply a number by itself x number of times, and we indicate this by that superscript right after the letter. Tetration is the next step, where you exponentiate a number x number of times. And there's a few ways this gets written, but I am used to seeing it either as an exponent on an exponent, or the Rucker notation, where the superscript is to the left of the base number, rather than the right like it is for exponents, or where that base number is followed by 2 up arrows, then the tetration number, Knuth's up arrow notation. A single arrow between base and exponent would indicate just an exponent, and there is another level after this called pentation, which would use 3 arrows. I have never seen this used outside of math, and that's just for the purpose of explaining that it exists. This rises very fast, so in hyperoperation 0, 1 is followed by 2, again just counting. In hyperoperation 1, addition, 1 plus 1 is 2, and 2 plus 2 is 4, and 3 plus 3 is 6, etc. In hyperoperation 2, multiplication, 1 times 1, 2 times 2, and 3 times 3 are 1, 4, and 9 respectively. In hyperoperation 3, exponentiation, 1 to the first power is 1, 2 to the second power is 4, 3 to the third power is 27, 4 to the fourth power is 256, 5 to the fifth power is 3125, and 10 to the 10th is 10 billion. It rises very fast, exponentially fast, pardon the pun. This is worse for tetration, where the first tetration of 1 is still 1, the second tetration of 2 is 16, the third tetration of 3 is 19,683, the fourth tetration of 4 is 340 trillion, trillion, trillion. So it rises up there really, really, really fast. And if that were in watts, it would be the equivalent to the power output of a major supernova or even a quasar, where 1, 2, and 3 would be a dim light bulb, a brighter one, and a lighthouse respectively. We won't bother giving an example for pentation, and for those curious there is also hexation beyond that, and hypothetically you could just keep going. Add more arrows or pick the next Greek prefix, hepta, octa, nona, deca, etc. We are not a math channel, and again, I have almost never used even tetration except when discussing multiverses or why you can create improbabilities so insanely unlikely that you don't need to ever worry about them, which comes up for concepts like brute force hacking modern encryption without a quantum computer, or building self-replicating machines with astronomically tiny odds of ever mutating as a quasi-species. Note that quantum computers can potentially brute force some of these tetration-level huge numbers, or problems, exactly by invoking the even huger and crazier scale of quantum and many-worlds multiverses. It can also be used to create encryption too, so it is not an unbeatable hacking tool. Short form, even in an entire universe our size full of monkeys with typewriters working for eons, it's very unlikely you're going to be getting any bestsellers out of it. The other aspect is that your default Library of Babel might have all the knowledge that can fit into a book, or any combination of books, volume 1 through 100, since every book exists, but your ability to find it is also no better than your ability to randomly generate it. You could spend your whole lifetime looking through that library and not find a single book that has single halfway legible first paragraph. So you could argue it's just as efficient to randomly generate gibberish as opposed to trying to find it in the library, and neither is going to get you any useful answers in the real universe. That said, You can cut these numbers down a lot by using some basic compression concepts. Instead of using random characters, you tilt the odds toward more common letters, RST, LNE, Wheel of Fortune style, instead of equal odds of every character and symbol. Incidentally, Pat Sajak just retired and aired his final episode of that show the week I wrote this. I grew up watching him and Vanna with my grandpa, and it's about the only show my wife and I watch with any regularity together. But I digress. You could also simply limit your pool to actual words instead of characters, and cut down your gibberish ratio a lot. There are a lot of words in English, but from a practical perspective, even most lifelong speakers of English know only around 20,000. And there's less than 1,000 that you'd ever expect to get used repeatedly in a given conversation. So a computer with a basic set of grammar rules could spew out some vaguely meaningful random sentences a lot more often than a Library of Babel book ever would. And obviously in this age of learned language models and ChatGPT, we can contemplate a lot more meaningful texts. If we imagine we were just doing a random library of 100-page long books of 400 words per page from that 1,000 word Common English, that becomes 1,000 to the 40,000th power, or 10 to the 120,000th power, which is still a number that's simply insanely huge, but is over 1 million orders of magnitude smaller than the default library. Our brains just don't handle these scales well, and even with years of studying the kind of physics where these scales come up, it's still utterly non-intuitive to me too. So for us it's hard to appreciate how much more plausible that is, but for a concept for 1 million orders of magnitude, it would be like winning the lottery 100,000 times in a row, and you'd have a lot better odds of winning the lottery than finding a single book with a sane opening sentence in an entire lifetime of searching the default Library of Babel. You still have better odds of getting a book like that than a randomly assembled brain that functions. A given neuron contains something like 100 trillion atoms in it, millions of times more than the number of characters in a book, and you've got 100 billion of those in your noggin. And as we've been demonstrating, the bigger your possible options for each spot, the more your numbers rise. But the number of spots you have makes it rise way, way faster. A library of all possible brain states is something worth contemplating though, because we might be able to store what's on a neuron on just a few atoms, much as we could store a word a lot smaller than we write it on paper. And realistically, you don't need every single variation for the same reasons. It doesn't matter if your random books are almost but not quite identical to some given masterpiece. By and large, 1 or 2 words, or memories, being different doesn't matter. Our minds are not static, and while we like to say we're the sum of our experiences, we don't really consider someone to be a different person just because they don't remember something anymore, and we don't really remember our life in ultra high definition anyway. We're also pretty sure that human memory is only in the low terabyte scale anyway, comparable to any of the several hard drives I keep around my office for storing copies of these episodes or stock footage. As we saw with the Library of Babel examples, a full copy of all human brain states would still be incomprehensibly huge, but it's not anywhere near the scale implied by random quantum resurrection or Boltzmann brains. This is fairly important to concepts like omega point cosmology, where the idea for surviving the end of the universe is to turn it into a big computer which, as the universe recollapses in a big crunch scenario, runs ever faster, so that on paper at least, an infinite number of calculations can be run, and in post-human computer mind terms, means every brain can be resurrected and run again, even if you didn't have a copy of it, since you have infinite calculation, and there's a finite number of brain states. In both this Big Crunch version and the standard heat death version, Dyson's Eternal Intelligence, you are not really going to get infinite calculations, so it helps if you can cut back those options to numbers that don't require black hole generating levels of matter to record them, especially as in our latter scenario, Dyson's Eternal Intelligence, we usually are planning to live near a black hole. See our Civilizations of the End of Time series for more discussion of that. Books and brains aren't the only variations of this though. We also have the Library of Mendel, our biological version of this, or at least DNA version of this. Here we only have 4 letters, G, T, C, and A, our nuclear bases, and genes are usually on an order of 1,000 to tens of thousands of these, so much shorter than a book. We should keep scale in mind when we're thinking of something like evolution though, because it isn't really random selections from the proverbial Library of Mendel. But even if it were, it's a lot smaller of an archive to be randomly working your way through. You could view Darwinian evolution as a combination of random mutations and non-random selection that finds functioning organisms in the Library of Mendel, those being the biological versions of meaningful books from the Library of Babel. But natural selection becomes a better approach than purely random processes could achieve, the monkeys banging at typewriters. For this reason, evolutionary algorithms were popular as a way to generate useful things out of a space of many possibilities outside of biology, but they seem to have fallen out of fashion recently in favor of machine learning-based algorithms. The shorter your code or book, the fewer versions there are, and the faster you can write it, and the more you can cram into one room. This was something we were touching on in our Fermi Paradox Rare Complexity episode, where we noted that virtually every organism alive is microscopic and has a lifespan of hours or days, and thus can go through random mutant combinations way faster than big organisms like us can. And yet it took billions of years before anything big enough to qualify as macroscopic emerged. We can apply this same approach to other macromolecules besides DNA, like proteins or polymers, as well as to basic chemicals and elements, in this case having infinite random monkeys trying to mix stable chemical compounds. It is worth noting that something like a protein with 100,000 atoms in it does not randomly assemble, any more than crystals do when growing, but builds off something smaller and simpler using emergent rules of chemistry. It could appear by random compiling, but is vastly more likely not to have, and so the only macromolecules we'll see are those that can self-build. The same reasoning applies to something like a Boltzmann brain too, where we would have true intelligences form randomly in a multiverse, complete with necessary hardware to sustain itself, but you would have vastly better odds of something forming that was very basic but able to grow in some fashion. A tiny machine and computer able to grow to a bigger one is vastly more likely than a fully formed random intellect, much as a basic life form is more likely than you or I. This summons an interesting idea to mind, a sort of self-growing library that only grew new nodules or books or rooms that contained useful books. Imagine instead our Library of Babel had grown its librarians and life support capacity simply to review what its finite monkeys were producing of apparent value. One could argue that this is exactly what we do as organisms evolved to intelligence who invented writing and libraries, and that our goal is to produce something like a total and complete library of useful information. This is the notion of the Encyclopedia Galactica that we hear about in Isaac Asimov's Foundation novels, and is what the Foundation was officially created for making, a universal repository of knowledge to survive the Dark Age they foresaw. Now, modern Wikipedia fits in a thumb drive and contains more knowledge than our civilization really needs to regenerate itself from any Dark Age, but if we were trying to imagine keeping all our knowledge of billions of worlds generated over billions of years, we might need something of galactic scale. But we do tend to contemplate civilizations of that scale here or even bigger, and it brings up another concept, the Akashic Records. The Akashic Records are a concept rooted in various spiritual and esoteric traditions, particularly in Theosophy and New Age thought. Derived from the Sanskrit word Akasha, meaning ether or space, the Akashic Records are believed to be a metaphysical plane containing a comprehensive record of all events, thoughts, emotions, and experiences throughout all time. This cosmic database is said to hold information about past lives, present experiences, and potential future outcomes for every soul. Practitioners claim that these records can be accessed through meditation, prayer, or with help of spiritual guides and Akashic record readers, offering insights into one's soul's journey, karmic patterns, and life purpose. We aren't going to comment further on the spiritual or religious aspects of the Akashic records, but obviously it would be nice to have some sort of multi-dimensional or higher dimensional equivalent to Wikipedia, the Internet or the Encyclopedia Galactica that was big enough to store a library of all knowledge, maybe copies of all minds, accessible anywhere and in some way usefully indexed. And indeed we could imagine libraries that were not limited to 3 dimensions in their layout, or which might be accessed from other places throughout the multiverse. And if that's the case, if such a thing were possible, then maybe we'd build it one day. But perhaps more interestingly, maybe somebody already did, and we just need to find it and how to access it, or who would issue us a library card. They do say that in the vast expanse of giant libraries, your library card becomes a passport to endless realms of knowledge, adventure, and inspiration. That statement might turn out to be more than metaphorical. We covered some interesting math today, looking at huge numbers and probabilities, and it is hard to understate how useful a solid understanding of probability can be in every avenue of life, and Brilliant.org can help you get that understanding and have fun while you do it. Whether you want to learn the basics or become an expert, Brilliant has an amazing and ever-growing catalog of lessons on probability and statistics. Build real knowledge in minutes a day, with fun lessons you can do whenever you have the time. Learn through problem solving and doing with hands-on interactive content that's fun, immersive, effective, and intuitive. Brilliant.org's content goes from the basics all the way up to advanced materials on math, science, data, probability, computers, and AI. Start where you need to and go as far as your dreams can take you. As we head into a new school year, equip yourself or a loved one with a study buddy that will help you excel. You can try everything Brilliant has to offer for free for a full 30 days. Just visit brilliant.org/IsaacArthur or click on the link in the description. You also get 20% off an annual premium subscription. So next week we'll be returning to the topic of space with a visit to the future cities of Mars. And speaking of space settlements, the National Space Society now has 2 contests opening up: the Live in a Healthy Space Design Competition and the Roadmap to Space Art Contest. The Roadmap to Space Art Contest is for ages 12 to 25, or grades 7 through university, for students to create their vision of a future for humanity in space through art. And the winning artwork will fly on a Blue Origin rocket up into space. Submission deadline is October 8, 2024. The Live in a Healthy Space Design Competition is for ages 12 to 18, grades 7 to 12, for students to design an agricultural module or area for a space settlement that focuses on a specific component such as infrastructure, food production, and resident nutrition. Submission deadline November 31st, 2024. For students, parents, and teachers wanting to learn more, just scan the QR code or use the link in the episode description. Show us your vision for the future and join us on the greatest adventure. And speaking of adventures, after our trip to the cities of Mars next week, SFIA turns 10 years old on September 17th, and we'll usher in our anniversary with a look at anachronistic technologies on Sci-Fi Sunday, like folks in space with laser rifles riding alien horses around on September 15th. Then we'll look at the concept of transcendence, moving beyond the physical or to a different layer of reality, and its implications for the Fermi paradox and our own future on September 19th. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show by becoming a member here on YouTube or Patreon, or check out other ways to help at isaacarthur.net. SFIA's episodes also come out early and ad-free on our streaming service Nebula, like this month's exclusive episode, Exploring the Multiverse, at go.nebula.tv/IsaacArthur. As always, thanks for watching, and have a great week.